खरा बेल शोक हुए बस तुम क्या लेट हेल लेट कहीं हेल पानी पील 15 मिनट ओके किसी क्वेश्चन ट्राई कल द असाइनमेंट दैट वाज गिवन yesterday the answer key also given so any doubt no okay so now I am going to discuss some important topics from alkyne then we will go to haloalkane okay alkyne so what are the preparation methods of alkyne केतरे प्रिपरेशन मेथड मन अच्छे एनसीईआरटी रे ओनली 2 गिवन आमे आउ दिटा एक्स्ट्रा डिस्कस करिवा सो फर्स्ट फ्रॉम डाइहालाइड सपोज यू आर टेकिंग so in order to prepare alkyne from dihalide we have to make the elimination method so for elimination which reagent is necessary that is alcoholic KOH so after removal of HCl it gives CH to double bond CHCl this is first elimination now in order to get alkyne you have to make another elimination yes or no so in order to make another elimination can you use the same base that is alcoholic KOH use kari pariba ki can you use no we cannot the reason is after formation of what is the name of this that is vinyl chloride yes or no so it has partial double bond character due to resonance so since partial double bond character is established so removal of the further HCl or HX is not easy that cannot be possible by the help of alcoholic KOH so we have to take the help of another strong base so what is the strong base you can take KNH2 यदि हम देखिबा in KOH what is the base OH minus or which is acting or which is used to take away the hydrogen that is OH minus so if we compare between OH minus and NH2 minus which is stronger NH2 minus is stronger okay NH2 minus is stronger so KNH2 can be employed for making the second elimination so this one is clear okay so you have to use KNH2 next second from CaC2 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 what is the structure of CaC2 it is ionic compound so Ca2 plus C2 2 minus बहुत जगह स्टूडेंट लिखंदी Ca sorry it is not Cl is it correct हमें जो बॉन्ड लाइन फार्मूला रिप्रेजेंट करछे कहाँ पे रिप्रेजेंट करछे फॉर शेयरिंग ऑफ इलेक्ट्रॉन so calcium carbide contains ionic bond as well as covalent bond between two carbon atoms covalent bond between calcium and carbon ionic bond so ionic bond को हमें bond line formula रे represent करि परिबानी so it has to be this is not the structure even some in refresher books this structure is given but this is incorrect so after hydration it will give calcium hydroxide acetylene and what is the use of acetylene sometimes it is asked The major use of acetylene is in metal welding. ଏବେ ମାନେ ଆସିଗଲା ଆମ ସମର ଆସିଗଲା, ସବୁଠାରୁ ଅଧିକ ଫ୍ରୁଟ୍ କେଉଁଟା ମିଳେ? ମ୍ୟାଙ୍ଗୋ, ମ୍ୟାଙ୍ଗୋ। ଓକେ, ସୋ ମ୍ୟାଙ୍ଗୋ ଦେଖିଲେ ଗୋଟେ ହ୍ୱାଇଟ୍ କଲର୍ର କିଛି ଗୋଟେ କୋଟିଂ ଥାଏ, କ'ଣ ସେଇଟା? ତା କାର୍ବାଇଡ୍ କୁହନ୍ତି ଇନ୍ ଜେନେରାଲ୍। ସୋ ଦ୍ୟାଟ୍ ଇଜ୍ ନନ୍ ଅଦର୍ ଦେନ୍ କ୍ୟାଲସିୟମ୍ କାର୍ବାଇଡ୍। ଯଦି କିଏ ମାନେ ଗାଁକୁ ବିଲଙ୍ଗ କରିଥିବ ଆମ୍ବଳି ଦେଖିଥିବ, ସୋ ସେଥିରେ କ'ଣ ନା ଗୋଟେ ଚକ୍ ଟାଇପ୍ର ଆସେ, ତାକୁ ମାନେ ୱାଟର୍ରେ ଲଗେଇକି ତାପରେ ମ୍ୟାଙ୍ଗୋ କି ଯେକୌଣସି ତୁମେ ମ୍ୟାଙ୍ଗୋ ଜ୍ୟାକ୍ ଫ୍ରୁଟ୍ ଅର୍ ବନାନା କେଉଁଠି ତୁମେ ତାକୁ ରଖିପାରିବ। ସୋ ହ୍ୱାଟ୍ ଇଜ୍ ଦ ୟୁଜ୍? ନା ଇଟ୍ ପ୍ରଡ୍ୟୁସେସ୍ acetylene gas, and acetylene gas is used for the ripening of the fruits. Acetylene gas is used for the ripening of the fruits, and another major concern is it is carcinogenic. It is carcinogenic. Okay, so that is beside the point. So this is acetylene gas. अच्छा, these two methods are given. जेमते हम कहबा नीट जनरल्स माने एनसीईआरटी फॉलो करछंती, बट एनसीईआरटी ए दुटा मेथड अछि, बट ता बियॉन्ड हमु किछि एक्स्ट्रा मेथड करिया पड़िबो। Third is preparation of higher alkynes. Preparation of higher alkynes. आम दुईटा मेथड कौन देखिले? Only acetylene is prepared. So how to prepare higher alkynes starting from lower alkynes? Lower terminal alkynes. Remember lower terminal alkynes. Suppose we are taking this, we know ठीक है। Student clear? So this is this is terminal alkyne, and we know terminal alkynes contain acidic hydrogen. So this one is acidic hydrogen. Since this is acidic hydrogen, ठीक है सर, ठीक है। Okay, since this is acidic hydrogen, so hydrogen can be released by the help of alkali or active metal. Active metal के कैसे? It can be sodium, potassium, aluminum, magnesium. So suppose we are taking sodium here, so it releases, this is sodium alkylide along with hydrogen gas. So it reacts with haloalkane. It reacts with haloalkane to prepare higher alkyne. So starting with lower terminal alkyne, terminal means triple bond must be present with the carbon number 1. Starting with lower terminal alkyne, we can prepare higher alkynes. आइटा मन रखो, this method is useful in preparation of many organic compounds. जेमते जानचो कार्बन जोटा हम थाए कोन गोटे गोटे ascending series और descending series. Ascending means how to increase the carbon number. So the best method is, or the simplest method is Wood's reaction, जो थे carbon number exactly double हबो. Then another is Grignard's reagent. We can use Grignard's reagent for the ascending order, for increasing the carbon. यदि गोटे कार्बन increase करिया थिबो, we can use KCN along with haloalkane. Yes or no? And if you want to increase more carbon, this is also one of the method. So if alkene or alkyne is given, then from that alkene or alkyne we can prepare this. Clear? Achha. One more method I am going to discuss, that was also asked in I think 5-6 years back in JEE Main once, from trihalide. Suppose you are taking chloroform, CHCl3 along with this silver metal, so how many silver metal? 6 silver metal. Not only chloroform, we can take any trichloroalkane. We can take any trichloroalkane. Okay, so at the place of H, if you are taking R, then that will be higher alkyne. So I think these four methods are enough. जदि आसो आर भितर ही आसो ताठू अधिक आसोनी. Okay. So clear? So quickly note down. Quick. अच्छा एपटे रखिले. अच्छा अच्छा इको हो कि okay students, written. Now chemical properties. So from the chemical properties, the major one is the acidic character. Alkynes are highly acidic in nature. Why? Due to the presence of hybridization. What is the hybridization? Sp. So we know more the percentage S character, more is the electronegativity. More the electronegativity, more is the acidic strength. Okay. So alkynes are more acidic than alkene, then followed by alkane. Then among the alkyne, if we'll compare the acidic character of terminal alkyne, let's say, and intermediate alkyne, this one is much higher acidic as compared to the intermediate alkyne. The reason is here the hydrogen is present with sp hybridized carbon, but in next case it is not so. Okay, so clear. Next, and other properties, addition. I am not going to discuss in detail. Addition, first one is addition of hydrogen, that will form simply alkane. Then addition of halogen, that will form which halide? In case of alkene, alkene forms vicinal dihalide, and here it will form geminal dihalide. With the same carbon, two halogen will be attached, because it is following the Markovnikov rule. Yes or no? अच्छा, next, hydration reaction. एटी तुमको ए रिएक्शन टा मन रखिया पड़े. ऑलरेडी तुम पढ़ी थिबो 12 क्लास रे, प्रिपरेशन ऑफ aldehyde and ketone. Suppose you are taking, so we cannot make the direct hydration. For that we have to take the help of HgSO4 and dilute H2SO4. So in first step, the hydration gives enol. Hydration gives enol, but we know between keto and enol which is more stable. In general, keto is more stable. Okay, can the enol be more stable? ना सब कीटो ही मोर स्टेबल हम. बुझिपाल क्वेश्चन? सब कीटो ही मोर स्टेबल हम ना केबे इनल भी मोर स्टेबल हो पारिबो. Enol can be more stable under two conditions. First, if the enol is aromatic in nature. Second, if the enol can be stabilized by intramolecular hydrogen bonding, not intramolecular hydrogen bonding. ताले जे चाहूचो एटा लेक्चर तापर मु तुमको डिक्टेट कर देबी. ए दुटा पॉइंट बेर क्वेश्चन आसे. So enol undergoes tautomerization to form aldehyde or ketone. Suppose you are taking same, so it will give again by following Markovnikov rule. Then hydration करचे, that is again by following the Markovnikov rule. So once enol is formed, that undergoes tautomerization to make the aldehyde or ketone. Aldehyde होबो केवल इथाइन रो, बाकी जेते other alkynes अछंती those will form ketone as the major product. Okay, अच्छा. So now you can note down one small point. Ratio of keto enol form. We know keto and enol are present in the equilibrium. Again, that is dynamic equilibrium. And equilibrium means both the reactant and product will be present, coexist together. Yes or no? So equilibrium means both the reactant and product will coexist together. ताମାନେ कहले कीटो इनल इक्विलिब्रियम रहिबे. So equilibrium doesn't mean that equal. Equilibrium एटा हे पारे reactant 10%, product 90%, or reactant 99%, product 1%. Both has to be present. बुझि पाछो equilibrium माने दीटा रहिबे. एमति नुहे जे दीटा को 50% रहिबे. If 50%, then that is the special case, but it is not the mandatory case. Are you getting? अच्छा ताले देखिए कीटो इनल भितरे which is to be major product and which is the minor product. In general, keto is the major product in general, but enol can be major if it is aromatic. Enol can be major if it is aromatic in nature. One example we can take. Suppose this one. This is the keto form. What is its enol form? Its enol form is this, and this is major. One question was asked once. This is keto form or not? This is keto form. Its enol form is in this case enol form is the major product. Why enol is major product? Because enol is stabilized by aromatic character. Okay, enol is stabilized by the aromatic character. So this is first one. Edire example lekhi paribo where due to the aromatic nature of enol form it is more stable than the keto form. Students, all of you got this? And one more, second point is intramolecular hydrogen bonding. Intramolecular hydrogen bonding. Suppose you are taking its enol form so this is stabilized by intramolecular hydrogen bonding. So this is enol and this is keto. So which is the major product? Enol is the major product. Why? Because it is stabilized by intramolecular hydrogen bonding. Okay. So for this particular compound, so as per the data I could recall, it is 75%, it is 25%. No need to remember the data. A data more mane achi, so I told. But एमती हम कहि परिया in general which is the major product, which is the minor product. But data is not necessary. Clear, students? Acha. So with this and other two, that is the polymerization. So in polymerization, it is linear polymerization and cyclic polymerization. Upon linear polymerization, that will form cyclo-di-ene, poly-ene. That will form poly-ene. Then the alkene ro polymerization कौन बनाऊचे? Polyalkane. एटा कौन हबो? Poly-ene हे जो, है ना? अच्छा. Then another is cyclic polymerization. So if 3 alkynes are taken, 3 alkyne means if you are taking 3 ethyne, that will form benzene. अच्छा रिएक्शन ते मन रखितो बेंजीन प्रिपरेशन किछि मेथड अछि. कोन मेथड अछि मन पका? गोटे तमे 12 क्लास रे पढिछो फिनल रु. फिनल को यदि हम जिंक डाइऑक्साइड ट्रीट करिवा दैट विल फॉर्म बेंजीन. अनदर इज फ्रॉम अल्केन. अल्केन को हमें यदि कोन नबा that is chromic oxide, CrO3 or vanadium pentoxide, that forms, that is alkane mane कितने कार्बन इतना दरकार? 6 कार्बन इतना दरकार. N-hexane. So N-hexane will give benzene. Similarly, if you are taking ethane, so 3 molecules of ethane undergoes cyclic polymerization in the presence of red hot iron to form benzene. ये तीनटा ही benzene preparation method मन रखो, ताठ अधिक दरकार नहीं. बुझी पारलो? ये तीनटा ही रखो. गोटे हला तमरो N-hexane रु, आ गोटे हला इथाइन रु, आ गोटे हला फिनल रु. जिंक डॉट सहित फिनल रु हेला. Over. Next, now we are going to discuss haloalkane. Haloalkane, then haloarine. Preparation of haloalkane. Preparation of haloalkane. So what are the preparation methods you have read? Just try to recall. किसी तो मैं already hydrocarbon discuss करी सकते. First is from halogenation of alkane. From halogenation of alkane जोड़ा last class रा में discuss करते ले yesterday. Then another is from alkene. How to prepare haloalkane from alkene by addition of HX by following the Markovnikov's rule. अब आंटी मार्कोव रूल जोटा हम काली डिस्कस करना थी सो एबे हम डिस्कस करिबा. गोटे आल्केन तो बुझी परलो खाली लिखि दियो प्रिपरेशन खाली हेडिंग लिखि दियो देन यू कुड रिकॉल फ्रॉम आल्केन बाय हालोजिनेशन मेथड देन फ्रॉम alkene suppose this by following Markovnikov's rule. This is first method. Second, anti-Markovnikov's rule or Kharas effect. Anti-Markovnikov rule or Kharas effect. And remember, this follows the carbocation mechanism, and this one follows free radical mechanism. Second one follows free radical mechanism, and first one follows carbocation mechanism. Manoj ke janakar anti-Markovnikov. It is applicable only for the addition of hydrogen bromide again in the presence of peroxide. Again in the presence of peroxide. मन पड़नी आर मेकानिज्म कौन थिला खाली तुम ब्रीफ कर दूची. This peroxide will be converted to free radical in the presence of sunlight or UV light. That is the first step. So once the free radical is formed, that will attack HBr. So HBr का attack केले कौन करिवो? That will take away the hydrogen free radical. So remaining कौन रहिबो? Bromine free radical बोलिबो. बुझि पालो फर्स्ट स्टेप कौन हैला? This undergoes homolytic cleavage. That is peroxide. So oxygen with the bond सेटा break होबो, free radical बनेबो. Next step रे कौन होबो? ना this free radical picks the hydrogen to form bromine free radical. Now bromine free radical will attack to this. यदि ये bromine free radical attack करिवो, so there are two possibilities. If bromine free radical is attacking to this, then this is the free radical formed. If bromine free radical is attacking to this carbon, this is the free radical formed. This is tertiary, this is primary. Which free radical is more stable? Of course tertiary. Since tertiary is more stable, so it leads to the final product formation by picking hydrogen. This RO dot है. So last one है. गोटे RO dot already remaining अच्छी, and this is another RO dot. So two RO dot will be combined to give peroxide R2O2. I hope all of you got this. बुझा वाला mechanism. अच्छा. Now the question is, in the absence of peroxide, will it follow the Markovnikov or anti-Markovnikov? It will follow the anti-Markovnikov. In the absence of peroxide. Second, will it follow anti-Markovnikov? It will follow Markovnikov because it goes through the carbocation mechanism. Again, suppose we are taking other hydrogen halide, maybe it is the HCl, maybe it is HI, then can it follow anti-Markovnikov? यदि हमें ये compound को HCl and H2O2 ର presence ରେ करिवा, so what will be the product? This is the product or this is the product? Which is the major product? Markovnikov product is the major product. Why Markovnikov product is major product? Because it doesn't follow the anti-Markovnikov rule. कहीं follow करिवनी? HBR जदि follow करे कहीं follow करिवनी? ना इथे हमें जो गोटे step कही मन पकाओ second step जोटा हम propagation step कथा sorry initiation step कथा कहूचे जो कौन थिला HBr plus free radical that forms bromine free radical along with ROH or H2 हवा. So that step is highly endothermic in case of chlorine as well as iodine. So it is chlorine or iodine free radical बनिवनी. यदि chlorine iodine free radical बनिवनी then that is not going to make the anti-Markovnikov rule, rather that will make the Markovnikov rule. बुझा पड़ला हैला. So only it is applicable for addition of hydrogen bromide again in the presence of peroxide, not for the HCl, HI or HF. Okay, because one of the steps, that is formation of halogen free radical, is highly endothermic, that cannot be compensated here. बुझा पड़ला बंद हैला. अच्छा, सो आउ कोन मेथड अछि गोटे अल्कोहल सबठार अधिक तमे देखिथिबो फ्रॉम अल्कोहल. This is one of the major reaction. So alcohol रो हमें कौन करिबा? Now we can take PCl3. माने थियो स्टूडेंट तमरो एटा तो तम पढी के आसबे PCl5 SO Cl2 then HCl and ZnCl2 then Na bromide in the presence of H2SO4 and X2 in the presence of red phosphorus. Here X can be bromine or iodine. Manable student. So these are the methods by which we can prepare haloalkane starting from alcohol. So here it is RCl plus S3PO3. Here it is RCl plus POCl3 plus HCl. RCl plus SO2 plus HCl. Then RCl plus H2O. Then it is R bromide plus NaOH. It is Rx. Remember here it is only for sodium bromide, not for any other halide. एठी हमें जानले क्लोराइड के आयोडाइड नहीं परिबानी हैला. बट एक केस रे कोन ओनली ब्रोमीन एंड आयोडीन. वी कैन नॉट टेक हियर, वी कैन नॉट टेक इधर क्लोरीन और फ्लोरीन. बुझा पड़ला. अच्छा, जदि पचरा जिवो अमंग दीज व्हिच मेथड इज द बेस्ट मेथड? दिस वन SOCl2. व्हाई? Because byproduct जोटा बनला SO2 and HCl both are the gaseous byproducts, so it can be easily be isolated from other products or the major product. Okay, next आउ कोन मेथड तुम पढि चको? बोरोडिन हंसडिकर एटा नथिबो तमरो एनसेट रे. बोरोडिन हंसडिकर रिएक्शन. So it is silver salt of carboxylic acid. Silver salt of carboxylic acid reacts with bromine to form it is again allolysis. Write on this reaction Borodin Honsdiker reaction. Okay, Borodin Honsdiker reaction. Next, you might be knowing use of NBS. Janchai NBS. What is the full form of NBS? N-bromo succinamide. This is the structure of NBS. It is derived from succinic acid. So N-bromo succinamide. So it is mild brominating agent. It is mild brominating agent. Note down. It is mild brominating agent which makes bromination. Are you writing? it is mild brominating agent which makes bromination only at the last word. Why you are not writing? जे तमे why you are not writing? हाँ जान सब जान लेख अब से जिन फोकस कर जोटा तुम बोर्ड सिलेबस ना बट नीट अच्छी एनबीएस बोर्ड सिलेबस नाला कि बोरडिन हंसटिकर कि नाला ताले नोट कर दियो जब तुम जानी भी तापर भी नोट कर दियो इट विल बी अनदर प्रैक्टिस ओके स्टूडेंट्स एट तुम आस फॉर 20 days सो 20 days को मेमोरेबल बनाओ किसी शिखिकी जाओ नुहे सो राइट इट मेक्स ब्रोमिनेशन ओनली एट द allylic only at the allylic or benzylic position. Allylic benzylic माने कौन double bond next position रहिला. Suppose you have taken this compound by the use of NBS. This is the product. Suppose you are taking toluene by the use of NBS, the product will be right. Suppose you are taking the same reactant. The same reactant, this is bromine H nu, another bromine iron dark. Can you complete the reaction? The same reactant, that is toluene. So when the toluene is treated with bromine in the presence of sunlight and bromine in the presence of iron and in the absence of light, in the presence of iron and in the absence of light, then what are the possible products? Quick. Complete. Now see, here bromine in the presence of light, that will form the intermediate, that is free radical intermediate. So it is okay. Here the intermediate will be electrophile. So electrophile makes electrophilic aromatic substitution, and CH3 is ring activating and orthoparadiating. So the product will be at the ortho position and at the para position. And which is the major product? Para is major product. Why? Because at the ortho position more steric crowding is present. At the ortho position more steric crowding is present. तार सब para product ही मेजर हम ना केतोले ortho product ही मेजर है पारिबो. Good. Which hydrogen bonding? Intramolecular. Good. Within the molecule. अब मान के इंट्रामोलिकुलर हाइड्रोजन बॉन्डिंग के लिए मोलिकुलर स्टेबिलिटी को इंक्रीज कराए जेमते हमें कीटोइनल कथा देखी थिले आ जदि इंटरमोलिकुलर हाइड्रोजन बॉन्डिंग हबो देन दैट मेक्स द boiling point to be increased. Intermolecular increases the boiling point and intramolecular increases the stability. Okay, so up to this clear? Acha. So these are the methods in order to prepare haloalkane. Then the next method is halogen exchange. Next method is halogen exchange. So what is the need of making halogen exchange? Because yesterday we have discussed we cannot make the fluoroalkane or iodoalkane directly, because fluoroalkane formation is too reactive and iodoalkane formation is very slow. So we can prepare chloro and bromo. Again chloro bromo re eita bi dekhiya rabo. Chloroalkane formation is more reactive. Jodi am pakhare more than one different type of carbon atoms are present, then we have to follow only the bromination. क्लोरिनेशन केतବେଳେ करियो जदि आइडेंटिकल कार्बन थिबो जेमति हमर सपोज इथेन अछि मीथेन अछि और एन पेंटेन अछि सॉरी नियोपेंटेन अछि देन साइक्लो हेक्सेन अछि जोटी ऑल द कार्बन एटम्स आर आइडेंटिकल सेठी हम क्लोरिनेशन ब्रोमिनेशन किछि करि परिबा बट जोटी मोर देन वन डिफरेंट कार्बन अछि वी हैव टू फॉलो ओनली द ब्रोमिनेशन नॉट द क्लोरिनेशन तमने बुझि परलो सो क्लोरिनेशन ब्रोमिनेशन हमें करि परिबा देन व्हाट नेक्स्ट हाउ टू मेक फ्लोरो एंड आयोडो अल्केन स्टार्टिंग विथ क्लोरो एंड ब्रोमो अल्केन so for that we have to use this halogen exchange method okay halogen exchange method so in that there are two reactions one is Finkelstein reaction so it is for the preparation of iodoalkane so you can take chloroalkane it is treated with sodium iodide in the presence of acetone it forms iodoalkane along with NaCl. Now can anyone say what is the mechanism of this reaction? Of course it is the nucleophilic substitution reaction because iodine is substituting chlorine. Chlorine is being substituted by iodine. Yes or no? So यदि nucleophilic substitution है तब जानছো SN1 SN2 SNI NGP ताले which method is this? SN1 ना SN2? Yes. Medium कौन? Acetone. That is polar protic or polar aprotic? Polar aprotic. Polar aprotic है SN1 ना SN2? SN2. बुझ पहले केमते आइडेंटिफाई करिवो जदि पोलर एप्रोटिक अछि देन SN2 पोलर प्रोटिक थिले SN1 जदि अल्कोहल थांता एसिटिक एसिड थांता वाटर थांता देन इट माइट बी SN1 फर्स्ट क्लियर सेकंड नाउ द क्वेश्चन इज कैन यू प्रिपेयर sodium at the place of sodium iodide can you take sodium fluoride in order to prepare fluoroalkane नहीं परिबा की गॉट माय क्वेश्चन आम जमी कौन ना सोडियम आयोडाइड ने कैन यू टेक सोडियम फ्लोराइड चिंता करो यस नो वी कैन नॉट ना शॉर्ट्स रिएक्शन कहीं पढ़ता फिंकलस्टीन रिएक्शन तो दीटा कहीं था so we are going to discuss Schwartz reaction that means Finkelstein reaction is applicable only for the preparation of iodoalkane not fluoroalkane and others why because only sodium iodide is soluble in acetone and all other sodium halides are insoluble in acetone eta चाहूँ तो नोट कर लिख दियो only sodium iodide is soluble in acetone sodium iodide is soluble in acetone and all other sodium halides are insoluble in acetone तार भी रीजन कौन तापे हमको जीवा पड़े फजांस रूल पाखु पोलराइजिबिलिटी एंड पोलराइजिंग पावर सोडियम कॉमन अछि बुझि परलो ताले लार्जर द साइज ऑफ द आयन मोर इज द पोलराइजिबिलिटी more the polarizability more is the covalent character more the covalent character more is the solubility in the polar more is the solubility in the organic solvent बुझि परलो ताले मते के सोडियम आयोडाइड और सोडियम फ्लोराइड भितरे कहार कोवैलेंट कैरेक्टर अधिक सोडियम आयोडाइड रो व्हिच विल बी मोर सॉल्युबल इन द पोलर सॉरी मोर सॉल्युबल इन द ऑर्गेनिक सॉल्वेंट्स लाइक एसीटोन सोडियम आयोडाइड बुझि परलो सो सब पछरे किछ ना किछ रीजन अछि एटा भावन जे नहीं एटा अछि माने मु मन रखिदा पड़ो नो रीजन अछि बट समटाइम्स इट इज नॉट पॉसिबल टू एक्सप्लेन ईच एंड एवरीथिंग ड्यूरिंग योर क्लास 11 एंड 12 सिलेबस बट जहाँ भी तुम पढ़ुच केमिस्ट्री सो ऑल हैज सर्टेन रीजन ऑल हैज सर्टेन एक्सप्लेनेशन बट बेले बेले कौन हुए पॉसिबल हुए नहीं सब जिन तुमको ये माने 11 12 लेवल एक्सप्लेन करने से कौन कह जाए ओके आपको मन रखी दियो यस और नो ओके सो नेक्स्ट Schwartz reaction so in Schwartz reaction you can take एठी आमे चाहिए ब्रोमो अल्केन नहीं परिबा so in both the cases chloro and bromoalkane can be taken. It reacts with the fluorinating agents. So what are the fluorinating agents? COF2, then can you take AgF, then SbF2. These are the fluorinating agents. So that will form simply fluoroalkane. जब हमें previous case रे iodoalkane बने थे, लेटे fluoroalkane बनेगा. So this reaction is known as, I think Hg2F2 you can take. Okay, Hg2F2. Sorry. Next. Next is preparation of dihalide. Preparation of dihalide. So you can prepare dihalide starting from alkene and alkyne. जब हमें alkene रे halogen add करिबा in the presence of CCl4 medium, that will form vicinal dihalide. If you are going to add 2 molecules of hydrogen halide in alkyne, that will form geminal dihalide. So no need to discuss. Clear up to this? Okay. So with this, preparation of haloalkane is over. Now preparation of haloarine. So in order to prepare haloarine, first is electrophilic aromatic substitution reaction. Electrophilic aromatic substitution. We can take benzene or any substituted benzene. It can be treated with, then the previous dekhithile, like this, halogen, iron and dark. So this is one of the method that is known as electrophilic aromatic substitution. It can be benzene or it can be substituted benzene. Then substituted benzene tame jancho, there are how many types? 3 types are there. One is ring activating and ortho para directing. So which are ring activating and ortho para directing? The ring activating and ortho para directing can be strong plus I like alkyl group, or plus R, OH, OR, NH2, NHR, NR2, O, OCOR. So these are the groups are which are making ring activating and orthoparaditing. So what is the meaning of ring activating? Now these groups make negative charge inside the ring as a result of either resonance or hyperconjugation or inductive effect. बनोची ना नहीं? Suppose हमने phenol, मन बगा phenol structure, resonative structure. So oxygen is releasing electron to the ring. So in the ring, negative charge with oxygen positive charge. Similarly, हमने aniline नवा, aniline पे positive charge, ring रे negative charge. जब हमें alkyl group नवा, due to hyperconjugation, alkyl रे कौन रहेगा? Positive charge. और ring भीतर कौन आशियो? Negative charge आशियो. So all are making negative charge, hence ring activating. कहीं ring activating, हमें डिस्कस करते electrophilic attack. Electrophilic attack means electron deficient molecule. So electron deficient the molecule जब रहिबो, so those are making making available of the electron density inside the ring. So ring activating है गला. Towards the electrophilic attack. अब कोठी negative charge रहिबो at the ortho and para position. Yes or no? Since the negative charge is available at the ortho and para position, so those are ortho para directing. Ortho para directing. I hope all of you got this. I would like ring deactivating and meta directing. जोटा strong minus I रहिबो, suppose NH3 plus, NR3 plus, SR2 plus, and strong minus I गला. And minus R group, NO2 CR, sorry CN, then COOH, aldehyde ketone. So and SO3H, those are making minus R effect. Minus R means inside the ring positive charge. Positive charge कोटी बनिबो ortho and para position रे. So ortho para position को तो electrophile attack करी परिबनी. So मजबूरी रे कोटी attack करिबो meta position. तार पसंद रो position नहीं, but मजबूरी रे कोटी attack करी परिबो, but with slow rate. So for that reason it is ring deactivating and meta directing. Got this? And third category is also there. Ring deactivating but orthoparaditing. माने थरा मन्ने third category ring deactivating and orthoparaditing. तो एटा कोन ring deactivating for orthoparaditing केमति हबो? Those are none other than halogens. Halogens deactivate the ring because halogens make strong a point जानছো ना जानना ring deactivating and orthoparaditing केजन जानছো जानना quickly note कर दियो ring deactivating and orthoparaditing ring deactivating and orthoparaditing right due to the strong minus I effect of halogen ring becomes deactivating as halogen withdraws electron this point is clear अच्छा next halogen रो resonance effect कौन हबो plus r हबो ना minus r हबो plus r halogen contains lone pair next line but due to plus r effect it directs the incoming electrophile due to plus r effect it directs the incoming electrophile to the ortho and para position ए टाइप क्वेश्चन ऑलरेडी जेई और नीट रे मन रखी था सपोज हम ओएच नौचे ओएच इज शोइंग प्लस आर एंड माइनस आई यस और नो NH2 is showing plus r and minus I हमके halogen is also showing the same thing plus r minus I तेले आ पूर्व आमे तो कहीं सेठी डीएक्टिवेटिंग कथा कोन सेठी एक्टिवेटिंग कथा कहउथिले मन रखिता जोइटी भी halogen आसीबो halogen आसिला माने तार प्लस आर इफेक्ट को भूली जिवो केवल माइनस इफेक्ट को देखिबो बुझि पला ना नहीं सपोज हम कहबा एसिडिक कैरेक्टर बेसिक कैरेक्टर halogen रो माइनस आई कैरेक्टर देखियो प्लस आर इफेक्ट देखिबोनी यदि प्लस आर इफेक्ट देखियो देन आंसर विल बी रॉन्ग एटा पर क्वेश्चन ऑलरेडी जेई रे आछि सो जेई रे आछि सो नीट रे न आसी बोले किछि गारंटी नाही नीट रे आसपर केबे बुझि पल्लो सो halogen आसले तार माइनस इफेक्ट देखियो जेम दे क्वेश्चन आस्तिला लॉन्ग बैक जेई एडवांस रे which is more acidic first one why only inductive effect so inductive effect decreases with distance बुझि पारला inductive effect decreases with distance ताले मेटर रे अधिक inductive effect हबो ना पार अधिक हबो मेटर अधिक हबो ताले माइनस इफेक्ट यदि अधिक हैला माइनस इफेक्ट इंक्रीज द एसिडिक कैरेक्टर so that is the answer बुझा पड़ला to all of you okay so now so last point we have discussed this one preparation of the haloarine first electrophilic aromatic substitution no need to explain it next is Steinmeier reaction in Steinmeier reaction which reagent you have to take aniline is treated with nitrous acid so nitrous acid is taken in the form of NaNO2 and HCl it forms diazonium salt so this diazonium salt is treated with different halogenating agents Cu2 Cl2 okay plus N2 then Cu2 bromide then Ki side product you can write then HbF4 BF3 plus N2 plus BF3 plus N2, okay, plus HCl. So other side products you can write. Clear to all of you? So these are the preparation methods of haloarine. So note down. Student, I know I am moving very fast. Otherwise it is not possible to finish one chapter within the time of 1.5 hours. तमें सेटा बुझी पारछ हैला. So still जदि काहू कोई भी टॉपिक रे लागिवो जे एस यू कुड नॉट अंडरस्टैंड दिस, सो विदाउट हेजिटेशन आस्क. बुझी पारलनी आ 8 रो स्लो गले गोटे दिन गोटे चैप्टर सरीबनी. आम पाखे टाइम भी लिमिटेड अच्छे. बुझी पारछ हैला. सो मेजर मु सेही टॉपिक रे फोकस करछि जोटा तमर इंपोर्टेंट अछि कि एनसीईआरटी कि तुम बोर्ड सिलेबस नाही बट नीट पई सेटा नीड अछि ता ऊपर मेनली फोकस करछि. आ सब टॉपिक को टिके टिके तमर रिकॉल करै दोछि. डिफिकल्ट होन तो बुझी पारछ समस्ते ऑल ऑफ यू. अच्छा, सो ऑल आर कंफर्टेबल इन ओडिया नॉट जेमते चलछि ठीक अछि तो ना कि यदि ओडिया न बुझी पारछ देन टेल. बुझी पारछ समस्ते तो ओके बुझी पार तो भाई देखो from this diazonium salt how to prepare fluorobenzene. Okay, so that is different reaction that is there in the nitrogen containing compound. Haloalkane under deini, but you can prepare fluorobenzene from the diazonium salt. Okay, next properties of haloalkane. So there are major 3 reactions: nucleophilic substitution reaction, second elimination reaction, third reaction with metal. Nucleophilic substitution reaction, then elimination reaction, then reaction with metal. So these are the major reactions to be discussed under haloalkane and haloarine chapter. So nucleophilic substitution reactions are of how many types? 4 types: SN1, SN2, SNI, NGP. And elimination reactions are of 3 types: E1, E2, E1, CB. So first SN1. What about the nucleophilic substitution reaction? In nucleophilic substitution reaction, one leaving group and another nucleophile. So leaving group is replaced by the nucleophile. So this is the example of nucleophilic substitution reaction. This is the example of nucleophilic substitution reaction. Clear? So SN1, SN2 बेसिक प्रॉब्लम नथिबो तमे बोर्ड में पढ़ी के आछो त खाली ब्रीफ कर दउची. न्यूक्लियोफिलिक सब्स्टिट्यूशन यूनिमोलिकुलर SN1, न्यूक्लियोफिलिक सब्स्टिट्यूशन बाइमोलिकुलर that is SN2. Order of reaction 1 for SN1, order of reaction 2 for SN2, because in SN2 what is to be present? The haloalkane along with nucleophile in the slow step, but in the SN1 only haloalkane is to be taken. Next, which is the intermediate used in SN1? Carbocation intermediate. And which intermediate is used in SN2? That is the concerted mechanism, transition state. मन पड़ची transition state, that is 5 atoms are attached with the carbon, but एठी कोन थिला carbocation थिला. Next, यदि carbocation बनिवो, so before giving the final product it may undergo rearrangement to form more stable carbocation. So rearrangement is possible, but in SN2 it is not possible as the reaction is governed by the concerted mechanism. Concerted mechanism means both the bond formation and dissociation takes place simultaneously. ଯେମିତି ମୁଁ ଏମିତି ଏକ୍ଜାମ୍ପଲ୍ ଦିଏ, ସପୋଜ୍ 2 doors are there. ଜଣେ ଜଣେ ଗୋଟେ ଗୋଟେ କ୍ଲାସ୍ ମିସ୍ କରିଦେଇଥିବେ, ମନେ ପଡ଼ୁଛି କଲେଜରେ, ସୋ ଗୋଟେ କ୍ଲାସ୍ ମିସ୍ କରିଦେଇଥିବ, ସୋ ଦେଖିବ କ'ଣ ନା ଏପଟେ ଯେମିତି ଟିଚର୍ ବାହାରିଲେ ତମେ ସେପଟେ ଏଣ୍ଟ୍ରି କରିବ. ସୋ ବୋଥ୍ ଦ ପ୍ରୋସେସେସ୍ ଆର୍ ସାଇମଲ୍ଟେନିୟସ୍. କେବେ କରିଛ ନା କେବେ କରିନା? ସମସ୍ତେ ଭଲ ପିଲା, ସମସ୍ତେ ଭଲ ପିଲା, ଓକେ, ଦ୍ୟାଟ୍ସ ଗୁଡ୍. ସୋ ବୁଝିପାରିଲେ ଏମିତି ହୁଏ ନା ହୁଏନି? ସୋ ଏପଟେ ଦେଖିବ କ୍ଲାସ୍ ଆବସେଣ୍ଟ କରିଛ, ଟିଚର ଦେଖିଲେ ପଚାରିବେ, ସୋ ଯେତେବେଳେ ଦେଖିବ ସାର୍ ଏପଟେ ବାହାରିଲେ ତମେ ବ୍ୟାକ୍ ସାଇଡ଼ରେ ସାଇମଲ୍ଟେନିୟସ୍ ଏଣ୍ଟ୍ରି କରିବ, ତା ଦେହରେ ଗୋଟେ ସେକେଣ୍ଡ ବି ଏପଟ ସେପଟ ହେବନି. ସୋ ଦ୍ୟାଟ୍ ଇଜ୍ ଦ କନସର୍ଟେଡ୍. ବୋଥ୍ ବଣ୍ଡ ଫର୍ମେସନ୍ ଆଣ୍ଡ ଡିସୋସିଏସନ୍ ଟେକ୍ସ ପ୍ଲେସ୍ ସାଇମଲ୍ଟେନିୟସଲି. ସୋ ସେଠି ରିଆରେଞ୍ଜମେଣ୍ଟ କେତେବେଳେ ହେବ? ରିଆରେଞ୍ଜମେଣ୍ଟ ହେଇପାରିବନି. ନେକ୍ସଟ, polar protic medium is favorable for SN1, polar aprotic medium is favorable for SN2. SN1 goes through racemization of configuration, whereas SN2 goes through inversion of configuration. कहीं देखो SN1 रे कौन होची? After the formation of the carbocation intermediate, after the formation of carbocation intermediate, the nucleophile will attack. So ता पाखरे both the positions are available. सपोज जमती कहली, सपोज टीचर नहांती, टीचर ऑलरेडी पळै छथि, 5 मिनिट आगु पळै छथि. सो तम पाखरे कोन दुईटा ऑप्शन अछि, यू कैन एंटर थ्रू द बैक गेट और थ्रू द फ्रंट गेट. तम पाखरे दुईटा ऑप्शन अछि. सो दैट इज both the inversion and retention can take place simultaneously. So that is known as the racemization of configuration. And another, student listen here, another, racemization doesn't mean that it is 50% inversion and 50% retention. It is also misleading. Complete racemization means 50% retention and 50% inversion. But in SN1 that is not the case. It already JEE रे गोटे थर पचारछि. It is more inversion and less retention. Why more inversion, less retention? Because after the departure of the leaving group, when the carbocation will be formed, the leaving group will be very close to the carbocation center. कहीं तांको coulombic force of attraction हबो हबनी. गोटे cation है गोटे anion है, although से departure है, dissociate है by the action of polar protic solvent, but that will be closer to the carbocation center. Why it will be closer to the carbocation center? Due to the coulombic force of attraction. So that is known as intimate ion pair. समस्त बायोलॉजी स्टूडेंट कहवा दरकार नहीं, गोटे जुइटर आयन पढ़ीच, अमीनो एसिड पढ़ना जुइटर आयन, अमीनो एसिड RNS R माने गोटे थो R थो, गोटे S थो, गोटे NH2 थो, गोटे कार्बोक्सिलेट थो, सब भूली गले ना कौन ना? तुम भीतर नॉन बायोलॉजी स्टूडेंट के अच्छा कि हाँ NH3 plus C, yes or no? So within the same molecule both positive and negative charges are there. So that is known as juiter ion. माने बोले बे जुइटर आयन कोडी फॉर्म हुए एटा पचार के थर क्वेश्चन पचार जेबिन बायोलॉजी रे पचार थिवो, केमिस्ट्री पचार जे बायोमोलिक्यूल चैप्टर रे माने बोला बे. So this is juiter ion, but एक केस रे कोन कहले कार्बोकेटन is different and the leaving group is different, both are not the same, both are not present with the same molecule or same species. So एक केस रे कहते intimate ion pair. So intimate ion pair हेले कार्बोकेटन आउ लिविंग ग्रुप पाखा पाखी रहिबे, ता माने जो साइड लिविंग ग्रुप अछि सेही साइड रे न्यूक्लियोफाइल को अटैक करे इजी होबो और इट विल बी डिफिकल्ट, इट विल बी डिफिकल्ट. कोडे इजी होबो ता अपोजिट साइड रु. ताले बे को रिटेंशन मोर होबो ना इन्वर्जन मोर होबो? इन्वर्जन मोर होबो एंड रिटेंशन. गोटे थोर जेई रे क्वेश्चन पचार थिला, SN1 इज तार ये थिला ऑप्शन थिला, जोटा करेक्ट ऑप्शन थिला रेसिमाइजेशन प्लस इन्वर्जन. बुझि पाला तार मीनिंग कोन? रेसिमाइजेशन प्लस इन्वर्जन means 50% inversion, 50% retention plus inversion. So that means more inversion. Clear? More inversion. So I hope all of you got this. Okay. So this is all about the SN1 and SN2 reaction. Any doubt in SN1, SN2? So now come to SNI. So it is the nucleophilic substitution internal. Quickly note down. SNI, it is the nucleophilic substitution internal. Nucleophilic substitution internal. That means the nucleophile is generated internally. That means the nucleophile is generated internally. So any reaction you remember related to SNI? मन अच्छे मन नहीं समस्ते जानी चा बट एटा जानना सेटा SNI रिएक्शन बोली अल्कोहल प्लस SOCl2 that is the example of SNI. Alcohol plus SOCl2. Just now we have discussed and all of you know this reaction very well. So SOCl2, alcohol, this is electrophilic center, this is nucleophilic center. Then what will happen? Pi bond will be dissociated. Plus, so next step, it will be released out and this one is going to attack this. So this will be okay. So again it is going to make the pi bond. So it will be SO2 plus HCl plus RCl. तुम जानছো P pi D pi bond is stronger than the normal covalent bond. नहीं कि मन पड़नी एटे बेले क्वेश्चन आसे what is P pi if the pi bond is formed between two second period elements, that is P pi. If the pi bond is formed between second period and third period element, then that is known as P pi D pi. Then suppose P double bond O, that is oxygen second period, phosphorus third period. So P pi D pi. Is that clear? Suppose you are taking oxygen double bond, that is P pi. Carbon double bond, P pi. All of you are getting this? HClO4. HClO4. Double bond is present between chlorine and oxygen. So that is the example of P pi D pi. Chlorine third period element, oxygen second period element. SO2, that is the example of P pi D pi. So when the second period element and third period element are involved in making the pi bond, so that is P pi D pi. Kete thora NEET re pachar PO gire dekhi paribo. Among the following which contains P pi D pi? Simply dekhibar achi koiti P pi hebo, that is two second period elements, CO2 P pi. NO2 P pi, because nitrogen oxygen both are second period element. जो गोटे भी थर्ड पीरियड एलिमेंट आसीबो, that is P pi D pi. Clear? That is P pi D pi. So it is clear. देखो, have you taken the chlorine or the nucleophile directly? No. You have not taken the nucleophile directly. Nucleophile is generated internally. आमे SOCl2 नहीं थिले. Chloride ion is generated internally. Yes or no? So this is the case of nucleophilic substitution internal reaction. Now the question is, it is following the retention of configuration, inversion of configuration or racemation of configuration. को साइड रे न्यूक्लियोफाइल अटैक करूची, जो साइड रे लिविंग ग्रुप अछि कारण सेउटु बनुची ना. So the living group and nucleophile both are present on the same side. So that will be the example of retention or inversion. That will be example of retention of configuration. आमे देखिले SN1 racemization, SN2 inversion and SNI complete retention of configuration. Complete retention of configuration. लिखि दियो SNI complete retention of configuration. NGPL neighboring group participation ता विषय में डिटेल डिस्कस करियो जाउनी. Here write NGP neighboring group participation. Neighboring group participation. It leads to the product formation by making retention in configuration. By making retention in configuration. Now listen. Here retention is taking place by making twice inversion. By making twice inversion. Jemti suppose ame gotte thara inversion hoba tale kon hobo, our head will be on the bottom, then further inversion, that is equal to retention. So ethire kon hochi se note ko likh paribo, inversion takes place twice. In NGP inversion takes place twice. So this is all about the nucleophilic substitution reaction. Acha tale me kemi janiba whether this is following the SN1 path or SN2 path. There are lots of similarity between SN1 and SN2. Haloalkane ame nauche, nucleophile nauche. So differentiate kariya pai, you know the order of reaction of SN1, that is tertiary, secondary, primary. Last one is methyl, and in case of SN2, methyl, primary, secondary, tertiary. So this is one major criteria in order to distinguish. ଯଦି tertiary ଅଛି SN1, primary ଅଛି SN2, ଯଦି secondary ଅଛି SN1 भी ହେଇପାରିବ, SN2 भी ହେଇପାରିବ. ସେଠି ଆମେ କ'ଣ ଦେଖିବା, the other cases. So what are the other cases? If the nucleophile is present in excess quantity. ଆମେ ଜାଣିଛେ SN2 ର what is the rate of the reaction? R equal to K nucleophile as well as the substrate. If the nucleophile is present in excess quantity, that favors SN2. को केस है, secondary case है. Primary, tertiary तो किसी tension नहीं. If the medium is polar protic, then SN1. Polar aprotic, SN2. तो जानी पहला कोड कोड हमें distinguish करी परिवा. Okay. So these are the points you have to take care while distinguishing between SN1 and SN2. Okay. अच्छा. Next is elimination reaction. If the question will be asked, why does any chemical reaction take place? कहीं chemical reaction कहीं होची? Stability आने पे, तमने reactant का unstable अच्छी, reactant तो stable अच्छी. So the पच्चर जीवो गोटे is new products formed. Reaction हेले से ना new product हमको जी reaction कहीं क्या वो? यदि गोटे सेंटेंस रे पचरा जाए, the answer is in order to increase the entropy of the reaction. Most of the chemical reactions take place in order to increase the entropy of the reaction. माने बोलते gives free energy delta G equal to delta H minus T delta S. Delta S is entropy change. So minus T delta S कौन होगा? Negative होगा. So more the change in entropy, more is the negative value. More the negative value, more is the spontaneity. Because the reaction is spontaneous if delta G is negative. Reaction is non-spontaneous if delta G is positive. Reaction is at equilibrium if the reaction if the delta G value is 0. मन पड़ची? Hello. Now, why the elimination reaction takes place? What is the driving force behind the elimination reaction? कहीं के elimination reaction होगा? Now there are two reasons. One is in order to increase the entropy. Second is in order to relieve the strain of the molecule. Suppose you are taking C clear, this is base, yes or no? Clear? Achha. Now what is the bond angle in the first case? It is the tetrahedral bond angle about 109 degree 28 minute, and second case trigonal planar about 120 degree. So in which case more bond angle is present? In the second case, if the bond angle increase hobo, atom with the distance बढ़िबो. If the atom with the distance बढ़िबो, steric crowding decrease hobo. If the steric crowding decrease होबो, ताले stability increase होबो. बुझा पड़ला? यदि पचरा जीवो तमु square planar shape and tetrahedral shape, which is more stable? Tetrahedral. काहे की? The bond angle. Tetrahedral 109 degree 28 minutes, square planar 90 degree. So this is one of the reason to relieve the steric strain. Steric strain. Second, this is one reactant, it is giving the two products. One reactant gives rise two products. The entropy increase होबो entropy decrease होबो, increase होबो. जदि entropy increase होबो ताले reaction spontaneous होबो ना नहीं. So these are the two reasons. बुझि पारलो जदि पते elimination reaction काहे के होची, in order to decrease the strain in the molecule and in order to increase the entropy of the reaction. So these are the two major reasons behind the elimination reaction. Okay. Acha. So E1, all of you know, E1 is elimination unimolecular, E2 elimination bimolecular. In order to make the SN1, the reactant is haloalkane. E1, the reactant is haloalkane. SN1, you have to take the base and you have to take the nucleophile, and E1 you have to take the base. जे बेस हम से न्यूक्लियोफाइल भी पारियो. देयर इज लॉट्स ऑफ कंपटीशन बिटवीन द बेसिसिटी एंड न्यूक्लियोफिलिसिटी. बेसिसिटी एंड न्यूक्लियोफिलिसिटी जे बेस हम से न्यूक्लियोफाइल हो पारे, न्यूक्लियोफाइल से बेस हम. सपोज OH माइनस, OH माइनस नेचर कौन, बेस, ता नेचर न्यूक्लियोफाइल. Cl माइनस नेचर कौन, बेस न्यूक्लियोफाइल. ताले मैं डिस्टिंग्विश केमिति करिवा, बुझबेला बुझपारे मो क्वेश्चन. जदि आम हालोआल्केन नौचे, हालोआल्केन रे आम यदि आम OH माइनस नबा, सो इट कैन बी बेस, इट कैन बी न्यूक्लियोफाइल. सो वेदर इट विल मेक द सब्स्टिट्यूशन रिएक्शन और एलिमिनेशन रिएक्शन आम केमिति जानिबा. इट इज रियली डिफिकल्ट टू डिस्टिंग्विश करि होबनी. आम कहले रिएक्शन कंडीशन सेम, रिएक्टेंट सेम, ताले डिस्टिंग्विश केमिति करिबा. द मेजर डिफरेंस इज द टेम्परेचर. एलिमिनेशन इज फेवरेबल ओवर high temperature कहीं entropy increase होची, and substitution is favorable over low temperature or moderate temperature. Otherwise SN1 E1 with distinguish करि परिवनी, SN2 E2 with distinguish करि परिवनी. गोटे छोटो एग्जांपल दउची, मैं पढी से रिएक्शन, से रिएक्शन एग्जांपल दउची. जस्ट ट्राई टू रिकॉल द प्रिपरेशन ऑफ ईथर फ्रॉम अल्कोहल. इथानॉल रु ईथर बनैथिलो, आ इथानॉल रु आमे अल्किन भी बने देखिजे खाली. So ethanol ether केमिति बनेबो, by the help of concentrated H2SO4. So how to prepare the ethoxy ethane from ethanol by the help of concentrated H2SO4. ताले reactant और reagent दुटा को सेम हे गेले. ताले केतोले ethanol हबो, केतोले ether हबो. ethanol हबो at 443 Kelvin, ether केतोले हबो 413 Kelvin. So ether means that is SN2 reaction, nucleophilic substitution. Ethanol means that is एलिमिनेशन रिएक्शन, माने जोटा तमरा इथिन जोटा हबो, दैट इज एलिमिनेशन रिएक्शन. बुझा पड़ला. सो एलिमिनेशन इज फेवरेबल ओवर हाई टेम्परेचर, सब्स्टिट्यूशन इज फेवरेबल ओवर लो टेम्परेचर. आउ बाकी आकु छाड़ी देले आ कोई भी माने एमती क्लियर कट कंडीशन नाही जो थरा में एलिमिनेशन और सब्स्टिट्यूशन को सेपरेट करि परिबा, डिस्टिंग्विश करि परिबा. अच्छा, आमे जेमति कहले अल्कोहलिक KOH को आमे यूज करिकि एलिमिनेशन करि परियान कोइथरे मैं टिके पूरा डिस्कस करथिली इन द अल्काइन चैप्टर, दैट इज the vinyl halide cannot undergo elimination to form alkyne. बट गोटे बुक अच्छी तुम मैंने मे बी ना शुणिथिबो, IL फिनर ना शुणच, ऑर्गेनिक रो बहुत भलो बुक गोटे, माने 11-12 बुक नो बट गोटे स्टैंडर्ड बुक, बट ता देर मेंशन होईची सेठी भी एलिमिनेशन हेई परिबो, बट ताकू छाड़ देले बाकी कोनोसी बुक रे मेंशन हेनी. बुझि पारलो. अच्छा, सो अप टू दिस क्लियर. अच्छा, ये E1 E2 कहिया दरकार अछि कि, आई डोंट थिंक E1 E2 दरकार नहीं, ऑलरेडी तुम पढिछ. E1 कार्बोकेटन इंटरमीडिएट, E2 कंसंट्रेटेड मेकानिज्म. बट एठी जो तुम सेठी कोन थिला SN1 आ SN2 रे थिला ऑर्डर ऑफ रिएक्शन. SN1 थिला टर्शियरी सेकेंडरी प्राइमरी, SN2 थिला प्राइमरी सेकेंडरी टर्शियरी. बट एठी E1 हो कि E2 हो दीटा रे कोन टर्शियरी सेकेंडरी प्राइमरी. व्हाई, काहेकि व्हाट इज द ड्राइविंग फोर्स ऑफ द एलिमिनेशन रिएक्शन to relieve the strain of the molecule. तमाने जोटी strain अधिक थिबो सेठी इजीली एलिमिनेशन हबो. strain कोठी अधिक अछि, टर्शियरी हालोअल्केन हबो ना प्राइमरी हालोअल्केन हबो, टर्शियरी. ताले एलिमिनेशन कोठी फास्टर हबो, टर्शियरी. बुझि परलो. एठी स्टूडेंट कंफ्यूजन होंती. सो E2 भाबिला लु सेटा प्राइमरी सेकेंडरी टर्शियरी कहि दियंती, बट द आंसर इज टर्शियरी ग्रेटर देन सेकेंडरी ग्रेटर देन प्राइमरी. द रीजन कोन ना ड्राइविंग फोर्स. यदि म कोन के बेसिक जदि बुझिबो सो को जिंस रे किछि कंफ्यूजन आसीबनी. And the last one for today, that is E1CV. E1CV. तमने लेट रास्ता मुझे सेमती लेट जाए क्लास ने भी बेसी ना 5 मिनट. नेक्स्ट क्लास कहते 4:45 ना, 4:45 तो ठीक है, 5 मिनट एक्सट्रा नेले चलिबो. E1CV एटा तुम पढ़ी नथिबो राइट एलिमिनेशन यूनिमोलिकुलर in the presence of conjugate base, right? Elimination unimolecular in the presence of conjugate base. Student, we'll go to the question first. What is the product? What is the product? This Manaburji. Second one is Shedjev product. First one is Hoffman product. Second one is Shedjev product. First one is Hoffman product. केतजन Hoffman product जानी चाहो? Raise your hand. None no. ठीक है, मैं Hoffman product कोई देवी है ना? अच्छा. So Hoffman product तीनटा केस रे हुए. केतोले जेतोले poor living group थी वो like fluorine. Second जेतोले bulky base थी वो. A third जेतोले conjugated double bond बनो थी वो. Okay. So write E1CV when the living group is poor living group. When the living group is poor living group, its elimination is not possible. Its elimination is not possible. So the reaction goes through the formation of carbanion intermediate which further acts as the conjugate base which further acts as the conjugate base to repel or to remove the leaving group that is fluoride. To remove the leaving group that is fluoride. एटी fluoride अच्छी है अच्छा. So this is one of the reason behind the Hoffman product. Now see. So first OH minus will pick the hydrogen. Hydrogen code number. This is primary, this is secondary. Which carbanion is most stable? Primary carbanion is most stable. So this is formed. So carbanion can act as the conjugate base. So carbanion ebe kon karibo na electron release karibo. So the carbanion electron release karibo, so the fluoride will be released. So I hope all of you got the mechanism. बुझ पालो फटाफट स्टेप लिख दियो. So this is one of the reason behind Hoffman product. When the living group is poor living group. और दीटा condition फटाफट करके क्लास को वाइंड अप करिया. I think tomorrow you have the first class, 8 o'clock. 8 o'clock ना. So आज ये मुझे क्वेश्चन देछि आपको सॉल्व करिवो. सो कल तो हालोआरिन एमती अछि बट हालोआरिन तो बहुत जिन डिस्कस करि सलेनी. आउ जा रिमेनिंग अछि सारी की देन विल गो टू अल्कोहल. ओके. So it is clear. Next second under the Hoffman product. Under the Hoffman product second, if the base is bulky base. If the base is bulky base. So do you know tertiary butoxide? This is tertiary butoxide. So bulky base. So if you are taking आपका में TBUO, this is the representation. Suppose this is chlorine. In the presence of tertiary butoxide, the product is Hoffman product. That bulky base rahila. Since it is bulky base, it cannot attack to the secondary carbon. Rather, it can comfortably attack to the primary carbon. So it can attack to this carbon as compared to this. ताले ये कौन प्रोडक्ट बनियो? Hoffman product है ना Shedjev product है ला? Hoffman product. Okay. And the last point. When there is a chance of conjugated diene. Conjugated diene. 1 minute. This. See, this is the chlorine. That they may double bond A side रे बनेगा. तले कौन आबो? It will have more number of alkyl groups around it. एक केस रे कितना double bond, कितना alkyl लेला? गोटे alkyl लेला. But एठी जो double bond बनता था, there will be 2 and 1, 3 alkyl groups. So more the number of alkyl groups, more is the stability of the alkene. That is according to the Shetzeff rule. But आमे एठी कौन लिखिले? Opposite product लिखिले. काहे की? Because conjugated diene. And we know conjugated diene is more stable as compared to the isolated diene. That is according to the resonance. Our Shetzeff rule को support किए करूँची hyperconjugation. Hyperconjugation resonance with which is more dominating. Resonance is more dominating. So I hope all of you got this. So these are the points behind Hofmann product. Otherwise ये तीनटा case सारी देले बाकी जहाँ तुम्हार case रहिला all are the cases of Shetzeff product. Okay students. Okay. So tomorrow whatever doubts you have come with your doubts. We'll discuss. Then we'll go to the other topics. Okay.